Today we're going to be working on multiplying integers. Now, in all my years of teaching experience, this is where kids start to mix up the rules. The rules for multiplying and dividing integers are not difficult. It's just they start to mix up the rules for adding and subtracting with the rules for multiplying. So you need to make sure you're really learning the process and taking your time when assigning positives and negatives. Let's first look at where multiplying integers comes from. We learned from an early age that when you multiply, let's say you're taking 4 times -5, that multiplication is repeated addition. So if you have 4 times -5, it's 4 groups of -5. So it's -5 plus -5 plus -5 plus -5. Using my rules for addition, I know that all of the signs are the same, so I add and keep the same sign. That's my rule for addition. If I look back at my multiplication problem, I have 4 times -5 equals -20. I had different signs in my problem, so different signs in my problem resulted with a negative. It is not negative because you have more negatives than positives, like the rule for addition would state. It is negative because the signs are different. That is why it is negative, different signs. So let's use a pattern to see what happens when the signs are the same. Let's start with 4 times -5, or -5 times 4, since we've already proved that. If I have -5 times 4, I know the answer is 20, -20. Negative because the signs are different. If I do -5 times 3, then, if I use that same rule, it's -15. I just multiplied, and it's negative because the signs are different. -5 times 2 is -10. Can you see how my answer is going down? Actually, up by 5 each time. -5 times 1 is -5. -5 times 0 is 0. So again, we're going up another 5 and up another 5. And now, when I get to -5 times -1, the pattern would state, if I add another 5, the answer would be +5, if you continue the pattern for the answers. So now, when my signs are different, they turned out negative. In this one, when the signs are the same, my answer turned out positive. So just like when we were adding integers, you have to look at if the signs are the same or if the signs are different, but the rules for those two situations aren't the same with adding integers. So let's get the rules written down for multiplying integers. If the two numbers have the same signs, the answer is always positive. So if they have the same sign, the answer is always positive. If they have different signs, the answer is always negative. It does not matter which number is bigger, which number, if it has more positives or more negatives. If the signs are the same, it's always positive. If the signs are different, it's always negative. So just a couple basic problems. If I give you -8 times 12, I know that 8 times 12 is 96. Multiplication means multiplication. and the signs are different, so my answer is negative. It does not matter that 12, the positive number, is bigger. All that matters is that the signs are different. If I give you, for example, negative 17 times negative 3, you multiply like normal. 17 times 3 is 51. And since the signs are the same, the answer is positive. It's as simple as that. Now, people start to get the addition rules mixed up with the multiplication rules. That's why I keep talking about how it doesn't matter which sign is bigger. You have to keep the rules separate and really think about the type of problem you are solving. So let's do a couple problems where it's multiple multiplications, or a number sentence, if you will, for multiplication. So if we're going to multiply 3 times negative 8 times negative 2, you need to remember that because it's all multiplication, you can multiply in any order. It doesn't matter. So I like to look for numbers that I know I can do in my head. I could start this problem with 3 times negative 2. I have 3 times negative 2, that is 6, and because the signs are different, it's negative. And then I write the rest of the problem, times negative 8, which I have left. I know that 6 times 8 is 48, and because the signs are the same, my answer is positive. You would get the exact same result if you start with 3 times negative 8. So if I would have started with 3 times negative 8, that would have gave me negative 24 times negative 2, that's what would have been left. And then a negative times a negative is positive 48. So you see how you would get the exact same answer if you would have started in a different order for this problem. Let's do an evaluate problem exactly the same way. If I tell you that A equals negative 2, B equals 3, and C equals negative 8. Okay, the problem I want you to solve is AB plus C. Okay, this is a little different than what we've seen. We have to understand that when you have two variables directly next to each other, what that means is you're multiplying those two variables. So when I plug in for A and B, I'm going to write that as A being negative 2 and B being 3. Remember, when you have two parentheses right next to each other, that means multiplication. So I know that's multiplication, and then plus negative 8. Now that parentheses is just separating the positive and the negative. Because of order of operations, you have to do the negative 2 times 3 first, because multiplication becomes before addition. So I have negative 2 times 3. Negative 2 times 3 is 6. The signs are different, so it's negative. And then plus negative 8. Now we're going to switch to our addition rules, and we're going to remember that when you add numbers with the same sign, you add 14 and keep the same sign. Now, if you were multiplying those two numbers, it would be positive. So you really have to keep these rules together, remembering that when you add negative 6 and negative 8, if you have 6 negatives and 8 negatives and bring them together, you now have 14 negatives. But when you're multiplying them, you end up with positive 48. You really have to think about your rules. So let's just practice some basic multiplication of integers, and then we'll move on to some other stuff. Good luck.